Hello everyone, this is Manish from Skillable India, and in today's session of geometric dimensioning and tolerancing, we are going to cover the third geometric characteristic symbol, which is about the circularity. Okay, so under the form control. Okay, so in this, which is circularity, which is the one of the part of the form control only. Okay, so here we take a with the definition first of all. Okay, so the circularity symbol this is the circularity symbol which we use in the feature control frame. Okay, it is round under the box. Okay, so is used to describe the circularity symbol is used to describe how close an object should be at a true circle. Okay, so circularity is a 2D profile, 2D geometric tolerance. Okay, which sometimes called roundness also. So circularity, another name is roundness. Okay, circularity is a two-dimensional tolerance. So circularity is a two-dimensional tolerance. Now you have to understand that it is similar to the straightness. Okay, so circularity is similar to the straightness. Straightness is also two-dimensional tolerance, and circularity is also a two-dimensional tolerance. Means that let's say this is a shaft. Okay, so this is the shaft, and if we are measuring the circularity, so we are measuring the circularity at every single point. Let's say this point, this point, these are the straight lines. Okay, so at any given point we are checking the circularity or the roundness. Okay, so this is not over the whole length. Okay, so this is the limitation of this. We are controlling over the single point because it is a 2D profile. Okay, so you can see this is a, let's say, plane, and if you cut down and at this point if we want to check the circularity, that it is circular or the round or not, so we can check at this point also, at this point also circularity, at every given cross section. So if I am word using cross section, so any given cross section we can check that the this is circular or not. Okay, so it is not handling the overall size of the shaft. Okay, it is for the single cross section area. Okay, so circularity is a two-dimensional tolerance that controls the overall form of a circle, ensuring, so here we are saying circle, ensuring it is too long, no, not too oblong. Okay, so whatever size in the cross we have provided, let's say in this case we have given 0.2 tolerance. Okay, so whatever the size of this, it will not come out of the 0.2 mm of tolerance. Okay, it can be, sorry, it is out now. You can see this, that whatever dimension we are providing over here, like this, it is not out of the 0.2 mm of tolerance. Okay, it is within the 0.2 mm of tolerance. So this is 0.2 mm of tolerance is applied in this section. Okay, here we have given 10.5 the upper limit, upper limit, and 9.5 is the lower limit. Okay, so whenever we are providing the tolerance, it is should be within the tolerance zone. Okay, it can be anywhere between 10.5 to 9.5, but the ups and downs. Okay, so the peak and valley or in this whole profile at any given cross section should not be more than 0.2 mm. Okay, so this is the very important thing. It can be at 10.5 where the where we required the perfect form, which is not able to manufacture as per the rule 1 we already know. Okay, so circularity tolerance zone defined by two concentric circles. Okay, so in this case you can see over here that these are two concentric circles, two concentric circles. This tolerance zone defined by the two concentric circles at any given cross section. Okay, so at any given cross section, this is defined by the two concentric circles. We have only dimension and the dimensional tolerance. Okay, first of all, we will understand about the limitations of the two important limitations of the circularity as a control we have. First limitation in this is first circularity measures how round something is and does not control the size. I have already told you that it is only measures at any cross section. Okay, it does not measure that it is not control the size. So it does not control over the size or the length of the part. It only controls the at a given cross section. Okay, so this is the first limitation of the circularity. The second limitation here we have is it is the circularity measures each tolerance zone in isolation. Okay, and it is not in the relation to each other. Okay, so whenever let's say we are measuring for a cone. Okay, so there is a cone like this, and if we are measuring at this point, okay, so we are measuring only for this top cross section. Okay, this is not for overall all length, and this circularity is not connected in and not in a relationship with the other with any with each other. Okay, so this is the second limitation in this circularity. Now, so whenever we have limit of size dimension, let's say whenever this is the limit of size dimension 10, if we are saying, so 10 dia 10 plus minus 0.5 over here is the limit of size dimension. Okay, and as per then rule 1 is automatically applied. So whenever there is a size dimension applied, the rule 1 applies. So we have two coaxial circle or concentric circle, we can say, at 10.5, dia 10.5 and dia 9.5. Okay, which is lower limit and the upper limit. So the actual surface lies within the two concentric or the coaxial circles. If I want to get better circular control, let's say if I want to get better circular control, so what we do is we have to apply the circularity tolerance in the feature control frame. Okay, so we have applied the circularity tolerance with 0.2 in a feature control frame. So we have to draw leader line. So we have drawn a leader line over here with the feature control within the feature control frame circularity and tolerance value. Geometric tolerance value we have provided 0.2, which is less than the tolerance dimensional tolerance value. Okay, so this is the very important thing. The geometric tolerance value, which is 0.2, is always smaller than the dimensional tolerance value. Okay, this is the very important part. Whenever we are providing straightness, flatness, circularity, or cylindricity, it is the tolerance zone will always be smaller than the dimensional tolerance value. Okay, so as we specified in the straightness and flatness, also this thing that the geometric tolerance value which we provide in the feature control frame is always be smaller than the circularity. Oh, sorry, dimensional tolerance value, which is plus minus 0.5. Okay, in our case over here. Okay, so there are two coaxial circles. I have already told you these are the two coaxial circles. This is the that is tolerance zone of the circularity. So this is the tolerance zone of circularity. Uh, if I give you the example, let's say, okay, so in this you can see this is a part. Okay, so at any given cross section, if I will check at this cross section, let's say if we are designing at any cross section, so let's say this is one of the cross section. If we are checking this part at this cross section, so we can apply the circularity. Okay, if in drawing we will see this thing. So we have provided the circularity over here. Okay, so at any given cross section of this part, it is circular at 0.1 mm. Okay, it does not mean that the part should be exactly in shape. Okay, if the shape is different, but the cross section should be within the tolerance zone. Okay, now if we take another part like this, okay, so in this part you can see that this at this cross section, the part should be at circular at 0.1 mm tolerance zone. Okay, let's say if I am using at this cross section, so then this cross section only at this size, this should be the within the tolerance zone. Okay, so because it is not controlling over the whole length of the part, it is only the any cross section, given cross section. So in this part, this is a cross section. Okay, so this is a cross section and this one is also a cross section. Okay, any given cross section over the length, it should be within the tolerance zone circularity. Okay, So this is one of the part. If we take an example of a sphere, okay. So in a sphere also, I have divided with the help of planes, okay, just to showcase you that at any given cross section, let's say if I am taking a cross section like this, so at any given cross section, this point, or I will, if I will cut down in this way, okay, so it should be within the tolerance zone, which is any tolerance zone we can provide for the circularity. It can be 0.1 or 0.2, okay, and this will round. If I will showcase this, okay, so this can be there. Two circles will be there, two coaxial circles, which is a tolerance zone for this part, okay. So this is very important. Now we will move towards our presentation. Okay, so this is the very important thing. The actual surface lies within the two coaxial circles. Circularity is a two-dimensional entity. I've already told you at any given cross section. Okay, surface lies between the 0.2 mm apart in this case. So this is applied to a feature, and we cannot. So this is can be only applied to a feature. Circularity can only be applied. Circularity only applied to a feature. So it is straightforward that if we can only apply to a feature, so and not the feature of size, so we cannot use the maximum material condition and the least material condition in this circularity tolerance. Okay. So I've already told you about the two coaxial circles in this part. This is the tolerance zone. Okay. So this is the tolerance zone, and the peaks and the valleys should always be into these two coaxial circles or the two concentric circles. Okay. So this is all. Circularity is measured by constraining a part and rotating it around the central axis. Okay. So this can be done with the help of height gauge. Okay, where we can rotate the part at any given cross section, and we can check with the help of dial gauge or the height gauge that the profile is exactly round or not. Okay. So if it is not round, it will show into the dial gauge. Okay. So if it is under the while putting on the V block, okay, so we can check the roundness or the circularity of the part. It should be within the tolerance zone or not. Okay. So this is how we measure the roundness of any cross section at any cross section. Okay. So this is all about the circularity. So thank you all of you. This is the third part of the under the form control, which is circularity tolerance zone. In the next discussion, we are going to discuss about the cylindricity. So thank you everyone.